we're starting the square root method. Okay, I love the square root method. But the first thing, before we get started on the square root method, you have to understand what a square root does. Yes? Okay, do y'all know what the opposite of square root? Squaring. Okay, so if I have x squared and I take the square root of x squared, the square root cancels the square because they're opposites. So it would just equal x. Yes? So if I have the square root of 9, can't I rewrite 9 as 3 squared?
Yes.
Yeah? Is it 9 squared, or 3 squared 9? So the square root cancels the squared, and that would equal 3. That's why the square root of 9 is 3. Because it cancels that pair, right? So that's what a radical, that's what that's called, is a radical or a square root. Yes? Do we kind of understand what a square root does? Okay, so knowing that, we're going to start the notes. Okay, so before we, No, you're fine. Before we start actually solving with radicals, we are going to learn how to simplify a radical. So when we have these, we do what we call the factor tree, because we have to figure out what's a pair. Because if I type the square root of 45, it gives me a super ugly decimal. That's not a simplified radical, okay? So we have to learn how to simplify it. So what we're doing is we're going to talk about prime numbers. Do y'all know what prime numbers are? 1 is a prime number, but does 1 change anything? No, it doesn't. So 1 is definitely prime, but we don't use 1 because if I divide or multiply by 1, does it change anything? No, so we kind of ignore that one. So you're right. So 2 is prime. Is 3 prime? Yes. Prime means only 1 in itself can be divided to give you a whole number answer. So like 2 can be divided by 2, it can be divided by 1, but there's nothing else to divide it by. So is 4 prime? No, because you can divide 4 by 2. Okay? What about 5? Yes. 6? No, because you can divide 6 by 2. 7 is prime. 8 is not. 9 is not. 10 is not. 11 is prime. 13 is prime. So on and so forth. There's a bunch more. But as long as you know kind of like these, you'll be fine. Yes? Okay. There are many different ways. This is a factor tree. Okay? You'll see that they don't do it the way I do it. I kind of have a method to keep it organized because we want pairs. Do y'all see how they have pairs and they circle them? Okay, you want your pairs to kind of be next to each other to make your life easy. So I start with my smallest prime number every single time. So does 2 go into 45? No. So what's my next prime number? 3. Does 3 go into 45? And if we're not sure, you can do 45 divided by 3. Does it? Yeah, so 3 and 15. And I stick with the same prime number, 3. Does 3 go into 15? How many times? 5. Okay, is 5 prime? Yeah. So guess what? We're done. When you get a prime number, you're done. So those are my prime numbers. I'm not looking at the 15 or the 45. I'm only looking at these prime factors. Now, if we did this correctly, because I want y'all to understand, 3 times 3 times 5 should give me 45. Did it work? Yeah, so those are the prime factors of 45. So pretty much, you don't have to rewrite it this way every single time. I just want y'all to understand the why first, and then I'll show you kind of the trick to remembering. So we could rewrite this as 3 times 3 times 5. Well, couldn't I also rewrite that then as 3 squared times 5? And didn't we just talk about how the square root cancels the squared? So the square root cancels the squared for the 3, but did it cancel for the 5? No, so the square root's still there for the 5. So this is our answer. Now, in simple words, think of the buddy system. Okay, you have to have a buddy to leave the house, the radical. So did 3 have a buddy? Yes. So 3 got to leave the house. Now, did I take out 2 3s? Or just 1? So when it has a buddy, you just take it out once. And it's because that radical canceled that second one. Okay? Now, the 5 did not have a friend. He had to stay home. Yeah? Does that make sense? So your leftovers go inside your food. your guy without a buddy stays inside. So this is how you do it. You don't have to write this every single time, but I wanted y'all to see the why when we only take out 1 3 even though there were 2. Does that make sense? Okay, so let's try the next one. So our next one is 96. Okay, and again, I'm going to start with my smallest prime number. I know 2 goes into 96, but I don't know how many times. So 2 goes into 96 48 times. Does 2 go into 48? Because I'm going to stick with the same prime number over and over. Yeah. 2 goes into 48, and I'm just going to cut it in half, so 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. And 3 is prime, so I'm done. Now, if you ever get to the point where you say, okay, 2 doesn't work, then you just try the next number. Like, you don't have to only use the same number. That just kind of happened here. So I have a bunch of pairs here. I have 1, 2, another 2. Do I have another pair? No. So what this means is I get to take out 2 twice because there were 2 pairs. And then I have 2 leftovers. I have 2 guys that did not have a buddy. I have a 2 and a 3 that have to stay home. Now we call this a factor tree, and factor means we're multiplying, right? That's why we're multiplying when we have more than 1. So 2 times 2 is 4, and then 2 times 3 is, there's your answer. Now, if you're not sure you did it right, you could do square root of 96, and then you could do, what's our answer, 4 square root of 6, and do y'all see how the ugly decimals match? That means we did it correctly. So if it's multiple choice, you could use your answer choices and see their ugly decimals. However, if it's not, yeah. But a lot of ours this year are not, so you will have to find them. Or some are drag and drop. Okay, 36, last one like this. Does 2 go into 36? Yeah, it's even, so 2 definitely goes in, and it's 18 times. 2 goes into 18 9 times. Does 2 go into 9? No, so now we go to the next prime number. Does 3 go into 9? Yes. How many times? 3, and 3 is prime, so we're done. What do you notice is different on this one? Yeah, they're both pairs. There's 2 pairs. Are there any guys that have to stay home? So then, well, guess what? We have no more radical. So what's 2 times 3? There's your answer. Now, this is what I want to explain to you. It's important that if you want, or you think it might be a perfect square, because 36 is a perfect square number, because 6 times 6 is 36. What's another perfect square number? Is 25, a perfect square number? Yeah, because 5 times 5 is 25. Is 1 a perfect square number? Yes, because 1 times 1 is 1. Okay, anything that has a double to multiply to give it to you is a perfect square number. So you can always double check what you're taking a radical of, and if it doesn't give you a decimal, then you don't have to do the factor tree. So like here, we did not technically have to do the factor tree, but I wanted y'all to see what happens. Cool? Okay, so knowing that about the factor tree and how to simplify a radical, we're going to go into actually solving with the square root method. Ooh, wrong button. Okay, so quadratics of the form. So what I want you to realize is to do this, you have to be able to have something squared. So we can't have just an x, which means the b term. So the only equations that you can do this on are when they're missing the b term. So they have to be ax squared plus or even minus c. They can have a c and they can have a squared, like an x squared, but they cannot have just that bx term. Okay? And you could see it different ways, which you'll see here in a second, but this is the form. So it can be solved using square root method. So here's our steps. So our first step is to isolate the square. So sometimes it's going to look like this, and sometimes it's going to look like this, and that's fine. So looking here, I have x squared. Is it already, good lord, is it already isolated? What's on the same side with the x squared? Minus 49. How do I get rid of minus 49? So I'm going to add 49 to both sides. So then I have x squared equals 49. So step 1 is complete. We isolated r squared. What's my second step? So it says take the square root of both sides. So we're going to square root both sides because we're trying to solve for x, and how do I get rid of a squared? With the opposite, which is a square root. That's why we're doing that. So square root cancels the squared on the left. And again, we're always going to check in the calculator because we're going to make our life easy. Is the square root of 49 a perfect number? Yes, it's 7. I don't know what they're doing over there. Okay, but I need y'all to realize something. If I square positive 7, I get 49, right? What if I square negative 7? Did I also get positive 49? And it's because two negatives makes a positive. So when we take the square root of 49, we have to realize that it could have been positive or negative 7 to give us that 49. So when you take the square root of a number, only when you're solving, you have to put a plus and a minus in front of whatever you got. Well, is x by itself now? Then we're done. We don't have to solve. So x equals, well, you don't have to write it like that. You can write it as negative 7 comma positive 7. There's two answers. Sometimes you'll see it too where they don't even separate it. They just put positive negative 7 inside brackets just like that. And that's fine. I don't mind whichever way you do it. I just need you to realize that this is two answers. Okay. Any questions with that? Yeah. So the big thing to remember is the square root of a positive number always has two answers. You have to have that plus and a minus. Okay, so I'm going to just highlight my squares. Okay, number 1, is my square isolated? Yeah, so what do? Square root both sides. So square root, square root, square root cancels the squared on the left, and I get x by itself. I'm taking the square root of a number, so I have to put that positive and that negative. And what's the square root of 100? 10. Because 10 times 10 is 100. So this is 10, and then we're done. So my answer is negative 10 comma positive 10. I'm going to write my answers different ways just so y'all can kind of see all the options. Any questions with that? Okay, look at number 2. Is my square isolated? No. What do I need to do to get it isolated? Divide by 5. There's no symbol here, which means multiply. The opposite of multiply is divide. Now I have x squared equals, what's 60 divided by 5? 12. 60 divided by 5 is 12. Okay, so now is my square isolated? Yes, so now I can take the square root of both sides. So square root, and I get x equals positive and negative. Well, we're going to check it. Square root of 12, does that give me a whole number? No, so that means we have to do the factor tree like we did at the top of our notes. So come over here, we're going to break down 12. Okay, I told y'all I'm going to start with my smallest, which is 2. 2 goes into 12 6 times. 2 goes into 6 3 times. 3 is prime, so I'm done. So what's my pair? So remember, buddy system, the 2 gets to leave the house. And then who had to stay home? 3. Now, is that still two answers even though I didn't separate it? Yeah, it's a positive 2 squared root of 3 and a negative 2 squared root of 3. I'm going to try to get through these two before lunch. Okay, here is my square alone. No, what do I need to move? So I'm going to do minus 25 on both sides. And I get x squared equals negative 25. Now what? Square root both sides. And we always check it in our calculator. So square root of negative 25, what does it say? What does that mean? No, because 0 is a number, so that would mean it touched at the origin. Would this ever touch? No, which means there's no solution. So you can't take the square root of a negative number? Two weeks.
So if it has a negative in the green,
so when you get to this point, if it has a negative in there, and like once you square root, then you don't even have to keep going. You literally just say no solution. So pretty much if we were to have graphed this one to solve by graphing, you would have an x squared here and a negative 25. Do those two lines ever touch? That's why. Okay. So yeah. Now, a lot of these you can do technically with the calculator method, like I just showed you. But you're going to see when we get to the back the ones that we can't do that method, and that's why you have to learn this method. Okay? With the calculator, because they give you super ugly decimals that we have to give you as simplified radicals. I'm not going to do number 4. We'll do it after lunch.
Let's do it.
Okay, number 4. Is my square alone? No. What do I have to do? Plus 5. Now, the reason I like showing this problem is because at first, isn't the right negative?
Yeah.
But when I add 5 to both sides, does it stay negative? So is this going to be a no solution? No. Okay, so now that my square is by itself, we're going to square root both sides. Square root cancels the squared. And what's the square root of 1? 1. So you might see the answer written like this as well. Because you can solve them with the calculator too. Now, any of the ones that have no solution or a whole number answer, like number 1, 3, and 4, could have technically been done in the calculator. However, number 2, you cannot do in the calculator because you wouldn't know that crazy decimal would turn into this. Does that make sense? And there's no way to make the calculator turn it into that for you. So that's why this problem would have to be done by hand. Does that make sense? We show you these ones because sometimes this is a lot easier to do than typing all of that in the calculator. However, it can be done either way. Okay, so let's look at number 5. Actually, we're going to skip to number 8. What's different about number 8? It has parentheses. But remember, I said we're getting whatever squared alone. And isn't this whole parentheses squared? Yeah, so as I highlight what's squared, it's the whole parentheses. So I have to get that by itself. Is it by itself? Is what's squared by itself? No. The whole thing is squared. Is it by itself? Yes. So I literally am just going to square root both sides. So square root cancels the squared on the left, and I'm left with x plus 1. And what's the square root of 16? 4. Now here's my question. Is x by itself? No. So what do I need to do to get x by itself? Minus 1. And I get x equals negative 1 plus or minus 4. Now, aren't those like terms? But positive and negative 4 are two different numbers. So what we have to do is we have to separate and simplify. So we get negative 1 minus 4 and negative 1 plus 4. Well, from there you can literally just type in your calculator. Negative 1 minus 4, negative 1 plus 4. So what are my two answers? Now, I'm okay if you don't show me this step of separating, if you're typing it in the calculator and getting the right answer, but I needed you to realize you can't just do up 3, positive and negative 3, because did this turn into positive and negative 3? No, you have to simplify it separately, okay? Okay, let's look at number 9.
why aren't we doing all of them?
Because I don't feel like we need to. And it's already a lot. Okay, number 9 is what's squared alone. So what do? What? No, we can't distribute it. You're going to have to wait.
Why?
We're dividing, because you can't put that in there because it's not squared. So divide both sides by 5. And I'm left with x plus 4 squared equals, that gives me 25. I want y'all to try to finish that. Ready, go. Oh, man. Just try. Follow what we did on number 8 and try. Okay, y'all should be trying. Pencils in your hands. What's my next step? No. That's inside parentheses. You can't move it. Is what's squared alone? Is what's squared alone? Yes. So what do I do? Square root. So square root cancels the squared. It is. So I get x plus 4 equals positive and negative. What's the square root of 25? 5. So I'm going to subtract 4 on both sides. And I get x equals negative 4 plus or minus 5. Well, I'm going to have 2 answers there, so we're going to type it in. Negative 4 minus 5. Ooh. And negative 4 plus 5. So what are my 2 answers?
1 and negative
9. Okay, number 10 is different. It's not different in the way we're going to solve it. It's different in the ways it's not going to give us a whole number. So what do I do first? Divide both sides by 3. And I get x minus 2 squared equals what? What's 24 divided by 3? 8. Is what's squared alone? Yes. So I have to square root both sides. Because this whole thing is squared and the whole thing was alone. Square root cancels the squared. And I get x minus 2. And then if I test the square root of 8, does it give me a whole number? No. So what do we have to do? The factor tree. So we're going to bring 8 over here and start with 2. Does 2 go into 8?
Yeah.
How many times?
4.
Does 2 go into 4?
Yeah.
How many times?
2.
2, and 2 is prime, so we're done.
15.
So I have a pair of 2's, but don't I also have this guy who has no friend? So that goes back inside. What did I forget? The plus and minus. So add 2 to both sides. And I get x equals 2 plus and minus square root. Oh, I forgot the 2. 2 square root of 2. Now, here's my question. Can I simplify this, do you think?
You don't have to.
You can't. Because these are not like terms. Radicals are kind of like variables. Can you combine 2 and 2x? No, because that first 2 didn't have an x. So same concept. If you want to combine something with a radical, the other one has to have a radical too. Does this 2 have a radical? No. So this is our answer. So our answer is, I'm rewriting it because I kind of squeezed that 2 in. So this is our answer. However, is that still 2 answers? Yes. Okay. It would be 2 minus 2 root 2 and 2 plus 2 root 2. So those would be them if they were decimals. Does that make sense? Okay. Last one we're going to do together is number 11. Is what's squared alone? No. So what do I need to do? plus 3. And I get x plus 7 squared equals 33. Now what? Square root both sides. On the left side, my square root cancels my squared, and I get x plus 7. And on the right side, don't forget our plus and minus. Now, if I square root 33, does it give me a whole number? It does not. It gives me an ugly decimal, so what do I have to do? The factor tree. So 33. Does 2 go into 33? No. Does 3? Yes. How many times? 11. Is 11 prime? So we're done. Does this have any pairs? So does it simplify? No. So we're going to do minus 7 on both sides. And I get x equals negative 7 plus or minus the square root of 33. And again, it doesn't simplify because you can't combine this with this. So there's our answer.